Okay, dear students, welcome you all for today's class 10 science class. Till now we have come to know what is heat, what is temperature, how these two terms are correlated. We have already come to know what are the sources of heat, what are the importance of heat in our daily life, that also we have come to know. And we have come to know that unit of heat, that is joule SI unit. Calorie is also a unit which is mostly used. What is 1 calorie heat, that also we have come to know, that the heat required to increase the temperature of 1 gram of water by 1 degree centigrade is called 1 calorie heat, that also we have come to know. Now one thing I would like to share with you, every day we do different activities, and while doing different activities actually we all burn the calorie, burn the heat of our body. You have to understand in that way. So generally a man in a day he burns around 1900 to 2500 calorie energy in one day. Similarly women around 1600 to 2000 calorie energy one has to burn every day. So anyway, and also we have come to know how the heat flows from one body to another body. Up to here we have come to know. Today we'll start. I have written for you the device to measure temperature. That is, we all know, we have seen whenever we go to a clinic, then what the doctor simply he come to us with the thermometer and he or she checks our body temperature. So we know that this is the very common word, thermometer. We are quite acquainted with this device, thermometer. So thermometer is a device actually which is used to measure the temperature of a body. So if you are asked what is thermometer, simple answer, thermometer is a device which is used to measure temperature of a body. Okay, name the device which is used to measure the temperature of a body. Answer is thermometer. Now we have to think on which principle does the thermometer work. So we know that whenever a body is heated, what happens with its volume? Definitely its volume increases, that means it expands. So the principle is that whenever a body is heated it expands, and whenever it is cool it contracts. Thermometer works on that principle, and especially liquid thermometers are used, and that's why we can also say that thermometer works. I have written here, thermometers are based on the property of thermal expansion of liquid. Thermal expansion of liquid means the same, that means it means whenever a liquid is heated it expands, and whenever the liquid is cool it contracts. So liquid thermometer works on that principle. Is clear? So if you are asked on which principle does a thermometer work, the answer is very simple. It works on the principle that whenever a body is heated it expands, and whenever the body is cool it contracts. Or you can simply say liquid thermometers, they work on the principle of thermal expansion of liquids. So in liquid thermometer generally two types of liquids are used, either mercury or alcohol. Okay, so you could be asked what are thermometric liquids. Very simple answer, the liquids which are used in the thermometer are called thermometric liquids. Name the thermometric liquids. Simple answer again, either mercury or alcohol you can say. Now why mercury? The question arises in our mind, why mercury is chosen? So there is the cause behind that. Actually, mercury has got a very wide range of temperature on which it remains in the liquid state. मतलब एउटा लामो रेंज अफ टेम्परेचर छ जसमा चाहिँ मर्करी लिक्विड स्टेटमै रहन्छ. Why? Because just I have written for you, its freezing point is minus 39 degrees centigrade. It means up to the temperature minus 39 it doesn't freeze. When it reaches minus 39 degrees centigrade, then only it starts freezing. And boiling point is 357 degrees centigrade. 357 degrees centigrade. It means when the temperature reaches 350 degrees centigrade, then only it starts boiling. That means it starts getting converted into gaseous form. So हामीले के बुझेँ मैले भन्दाखेरि मर्करी को फ्रीजिङ पोइन्ट माइनस 39 डिग्री सेन्टिग्रेड छ र बोइलिङ पोइन्ट 357 डिग्री सेन्टिग्रेड छ. यसको अर्थ के हो भयो भन्दाखेरि माइनस 39 देखि लिएर माइनस 357 डिग्री सेन्टिग्रेड सम्म मर्करी चाहिँ लिक्विड स्टेटमै रहन्छ. सो इट्स अ भेरी वाइड रेंज अफ टेम्परेचर. यसको मतलब धेरै ठाउँमा हामीले चाहिँ मर्करी को युज गर्न सक्छौं बिकज it remains in liquid state for a very big or very wide range of temperature. But one thing, now there are so many places on the earth where the temperature goes below minus 39. So in the very cold region where temperature goes below minus 39 degrees centigrade, there mercury thermometer doesn't work because it gets frozen. Okay, so that's why it cannot be used in very cold regions. So sometimes question can be asked, why mercury cannot be used in very cold region? Very simple answer. The reason where the temperature goes below minus 39, in those areas, in those regions, mercury thermometer cannot be used because the freezing point is mercury is minus 39 degrees centigrade. That means as soon as the temperature goes below minus 39, it freezes. That's why it doesn't work. So that's why for very cold region, mercury cannot be used as a thermometric liquid. So we have to think for another option. So another option is here, alcohol. Now alcohol, its freezing point is minus 117 degrees centigrade, whereas the mercury has got minus 39 only, but alcohol has got minus 117. That is far below than minus 39. Its boiling point is 78 degrees centigrade. So for a very hot region it doesn't work, but for the cold region where the temperature is going below minus 39, definitely we have to use alcohol thermometer. So for that sort of places, actually alcohol is used as a thermometric liquid. That's why generally two types of liquid thermometers we get, mercury liquid thermometer as well as alcohol liquid thermometer. And we all know our body temperature is around 37 degrees centigrade. Okay, 37, that is in Fahrenheit it comes 98.6 degrees centigrade. That's why mostly the temperature which is used for clinical purpose, or you can say clinical thermometer, in that thermometer actually mercury is used because it has got a range in between minus 39 to 357. Our normal body temperature is 37. So it may go 1-2 degree less or 1 to 2 degree more. So here mercury will work. So that's why clinical thermometer, the thermometer which is used to take our body temperature, in that thermometer mercury is used as a thermometric liquid. It's clear? I'm sure it's clear to all of you. Now let's talk about the SI unit of temperature. Actually SI unit of temperature is Kelvin. We write it as capital K, okay, Kelvin. But the thermometers are also actually calibrated. Generally mostly the thermometers, they are calibrated either in centigrade scale. centigrade scale, Fahrenheit scale or Kelvin scale. That means centigrade, Fahrenheit, these are also, Reaumur is also there. So, these are also the different units. Generally thermometers are calibrated either in centigrade scale or in Fahrenheit scale or in Kelvin scale. Now, they have one thing in centigrade scale, actually what is done actually for the, I will show you here the three scales. This is suppose centigrade scale, this is your Fahrenheit scale, this is your suppose Kelvin scale. What is done actually, 2 points are fixed, that is called lower fixed point and upper fixed point. Now, the question comes, what is this lower fixed point and upper fixed point? Lower fixed point is the actually the freezing point of water, okay, the temperature at which water freezes, that we call as lower fixed point, and the temperature at which water starts boiling, that is your upper fixed point. For centigrade scale, lower fixed point is actually your 0 degree centigrade and upper fixed point is 100 degree centigrade. So, what does it mean? It means water freezes at 0 degree centigrade and water boils at 100 degree centigrade. So, whenever we are making the liquid thermometer, so first on which scale we have to calibrate it. Suppose on your centigrade scale, so we have to understand that lower fixed point is 0 degree centigrade, upper fixed point is 100 degree centigrade. Similarly, for Fahrenheit scale, I have written here for Fahrenheit 32 degree Fahrenheit, 212 degree Fahrenheit. It means in Fahrenheit scale, the freezing point of water is 32 degree Fahrenheit, whereas the boiling point of water is 212 degree Fahrenheit. So, we have to first fix these 2 points. Similarly, for Kelvin scale, if we will talk about, for Kelvin scale, lower fixed point is your 273 Kelvin, whereas the upper fixed point is your 373 Kelvin. So, the very first thing which you have to understand, these three scales, okay, for centigrade scale, for Fahrenheit scale and for Kelvin scale, there are 2 fixed points, lower fixed point and upper fixed point. What is lower fixed point? Lower fixed point is the actually freezing point of water. So, in centigrade scale, that is 0 degree centigrade, and for Fahrenheit scale, that is 32 degree Fahrenheit, and for Kelvin scale, that is 273 Kelvin. Similarly, upper point, that is the upper fixed point. What is upper fixed point? That is the temperature at which water starts boiling. So, that is in centigrade scale 100 degree centigrade, in Fahrenheit scale 212 degree Fahrenheit, and in Kelvin scale 370 Kelvin. Now, these 3 scales, they have got a relation. That means we can convert the temperature in one scale to other scale. So, by which formula we can, or by which relation we can convert this, the relation. Suppose you have to convert centigrade into Fahrenheit, then you will use this, C upon 5 equals to F minus 32 upon 9. Or suppose if you have to convert centigrade into Kelvin, then what you will use, C upon 5 equals to K minus 273 upon 5. If you have to use Fahrenheit into Kelvin, then Fahrenheit and Kelvin, you will take this, F minus 32 upon 9 equals to K minus 273 upon 5. So, this is the relation for these 3 scales, centigrade, Fahrenheit and Kelvin. Now sometimes the question arises how this relation has come. So I will show you in a very simple way, try to understand. I will show you here. Suppose these are the three thermometers, okay, and I have shown the lower fixed point, upper fixed point for all these. Let's suppose a temperature in centigrade scale is here, suppose this, and for the same, if you will talk in Fahrenheit, for the same position it's here, for Kelvin it's here. So here it is your degree centigrade, it is suppose C. Here the reading is Fahrenheit, F. Here the reading is in Kelvin, I have written here K. Because this is the centigrade scale, so we are getting in degree centigrade. I have written how much value is here for the temperature, suppose C I have written, and in this scale F I have written, in this scale I have written K. They are at the same height I have taken, okay. Now suppose this length is X. Now what I am going to actually do right now, I am going to explain you how this relation has come, so that there shouldn't be any confusion, okay. Suppose this length is X, that means this length is also X, this length is also X, and from here to here, from lower fixed point to upper fixed point, suppose this is your L. So for this also, from here to here L, from here to here L. Now you just think here, you try to understand, okay. X will be, actually if you will see, X will be always directly proportional to just you look here in centigrade scale, okay. X will be always proportional to, because it begins from G, here is one reading C, so X will be equals to C minus 0, C minus 0, clear. If you will see here, because the reading the lower reading is 0, upper reading is C, then X proportion to C minus, because why I have written proportion, because if you are taking X, you can take here also, here also, here also, it may get changed, that's why proportion I have written. This X, length X may vary. Similarly, you have got it for centigrade scale. If you will talk about X, we can say X is proportion to C minus 0, okay. Similarly, L, if you will talk about, L will be proportional to, now this is, here it was C and it was 0, so it was C minus 0, but here it is 100 and here is 0, so 100 minus 0. No need to write 0, but I am writing because we have to understand, because for other scale there is no 0, so that's why you have to understand this is the difference we have to take, C minus 0, and for this L 100 minus 0 is clear. Suppose if you start from 10 and you reach up to, suppose in a scale 10 is here and you reach here 25, so what will be in between? How you will calculate? 25 minus 10, it will come 15. In that way we have to think. So here it is 0, here it is 0, and here it is C. So what will be this? What will be this X? C minus 0. 25 minus 10, 15 we had got, in the same way C minus 0, clear. But it may get changed, that C may come here, so again now X C minus 0, so that means proportion we have to write, okay. These two proportion, if you divide, you can write X upon L equals to C minus 0 is C upon 100 minus 0, C minus 0 upon 100 minus 0, okay, no problem. So this is for centigrade scale, we have got one relation. What is that relation? X upon L equals to C minus 0 upon 100 minus 0. Similarly, if you think for another scale, that is for Fahrenheit. This is x, same x, because we are going to find out the relation between these different scales. So that's why at same, what will be x here now? F minus 32. Don't get confused. 32, suppose it is 50, then what is in between? 50 minus 32. Here is 32, here is f, so f minus 32. Clear? So x proportion to f minus, why I am writing proportion, that also I have shown, because this f point may get changed. Is clear? So that's why we have to write proportion. And in this case L also same. Here now you, instead of from here to here, you can take L up to here also. No, that's why here also we have to write proportion. L up to here also it may we may take L here also. Okay, I mean the upper fixed point could be changed. So that's why L, this point may come here also like that. So L proportion 100 minus 212. Here is your from here to here is L. So what is L? L proportion we have to write 212 minus 32. So in this case also what we are getting, x upon L now is equals to f minus 32 upon 212 minus 32. Clear? Similarly, if you will think for Kelvin scale, same thing. What is x? Proportion to K minus 273. 273 K. What is x? K minus 273. So x proportion K minus 273. And L is proportion to 373 minus 273. 373 minus 273. 273, 373. So 373 minus 273, that will give. Okay. So in this case, x upon L will be equals to K minus 273 upon 273 minus 373 minus 273. Now look here, this is x upon L. This is also x upon L. This is also x upon L. All these three are same, x upon L. So we can write for this x upon L, C minus 0 upon 100 minus 0 equals to, this is x upon L, we can write this f minus 32 upon 212 minus 32, and this is also x upon L, K minus 273 upon 373 minus 273. If you see this, it will come, look here, C minus 0 is C. So C upon 100 minus 0 is 100. C upon 100 equals to f minus 32 upon 212 minus 32, it will come your 180, and this is equals to K minus 273 upon 373 minus 273, it will come your 100. And if you will see this, 25 ja 100, 29 ja 180, 25 ja 100. So the relation becomes now C upon 5 equals to f minus 32 upon 9 equals to K minus 273 upon 5. So in this way we can derive the relation between these three scales of temperature: centigrade scale, Fahrenheit scale and Kelvin scale, which already I have written here. C upon 5 equals to f minus 32 upon 9 equals to K minus 273 upon 5. Sometimes you could be asked convert, okay, this much degree centigrade into degree Fahrenheit. So, you have to use this formula. Clear? Suppose you are asked convert, suppose very simple question I am writing. Suppose you are asked convert 10 degree centigrade into Fahrenheit scale, degree Fahrenheit. So, what you will do? You will use this formula. Here we have to take only these two scales, centigrade and Fahrenheit. This is the relation, C upon 5 equals to F minus 32 upon 9, or C is this 10 degree centigrade. So, for in the place of C we will write 10 upon 5 equals to F minus 32 upon 9. I am showing you here, or 5 2s are 10, and so 2 upon 1 cross 1 into F minus 32, F minus 32 equals to 2 into 9, 9 2s are 18, or F equals to 18 plus 32. So, it comes here how much? 50. So, in this way 10 degree centigrade equals to 50 degree Fahrenheit. So, like this we can use this formula, okay, this we can use this relation. You could be asked convert this much degree centigrade into Kelvin, then C upon 5 equals to K minus 273 upon 5, we will use that. Understood? Okay, now I have written here, and that you can do yourself, you can write yourself, though if you go through the book, that also you will get very simple differences between heat and temperature. One thing, dear students, please be clear that whenever you are asked to write the difference between two things, if these things are physical quantities, any two physical quantities, if you have to write the differences, two differences very easily you can write. First you write the definition, then you write their SI unit. That will be your differences. For example, heat and temperature. So, you can write number 1, heat is a form of energy which gives the sensation of hotness or coldness of a body. That is the definition, simple definition of heat. For temperature, you can write temperature is the degree of hotness and coldness of the body. This is the sensation for hotness and coldness. Here is the degree. Degree is the measurement, how much hot, how much cold. So, temperature gives you the degree of hotness and coldness. So, that is one difference. Now, second difference I just told you, you write the SI unit. So, you can write SI unit of heat is, you all know, joules, and that of temperature is Kelvin, already we have come to know. Okay. So, these are the two differences. Other differences you can say, you have come to know already, that heat of a body is the total kinetic energy of the body, whereas temperature is the average kinetic energy of the body. That is one another difference. One more difference you can think, that heat is measured by what is that instrument, what is that device, already you have gone through, you have read, already you have come to know, that is calorimeter. So, heat is measured by calorimeter, temperature is measured by, just we have come to know, thermometer. So, that is one difference. Another difference, heat is the cause of the temperature. Due to heat, temperature actually is resulted. So, heat is the cause of temperature, and where is the temperature is? Temperature is the effect of heat. So, that is also one difference, that heat is the cause of temperature, whereas temperature is the effect of heat. So, in this way, so many differences you can write. So, for today my time is over, the bell has gone. So, up to this much only. See you tomorrow. Thank you very much.